Uh, Good afternoon, everyone. I want to welcome you to another consulting class. Before I get started today, I think I share information some minutes ago about the graduate panel that we're going to have on Friday. I need you to check the announcement section about the venue and for detail about the meeting. You're actually going to have opportunity to ask a question from uh, alumni of the university and from those who actually graduated from this program and this university that are now either in the civil service or research organization that are in different kind of companies. Of course, you're going to hear from them about their experience. Okay, so that is about the meeting on Friday. I've shared the venue on the canvas. Uh, Today, because you are currently working on independent research project, and of course, I remember the other time we met where I discussed a way to do scientific reports. But today, I want to show you already made research work and how they ended up writing scientific report based on their intention. I need you to take a look at what I'm displaying right now, and you look at the title. Look at the title, an explanatory analysis of data from drug abuse and warning network that we actually abbreviate as DAWN down. If you take a look at the title, this is telling you the interest is not on inferential statistics. The interest is only on explanatory statistics. Let me tell you this, explanatory analysis is different from, inferential analysis. In explanatory analysis, you only want to describe and what we normally the technique of statistics that we normally use here, they are basically in descriptive statistics. So in explanatory analysis, you know what we look into the trend, we look into the frequency, we look into proportion, we look into percentage and so on, like that. We just want to describe. We don't want to do anything inferential. Okay, we're not applying rigorous statistical model. Okay, so in explanatory analysis, um, we actually going to go more of graphical summary. Okay, so if you pay attention to the title, of course, the direction of the analysis has been specified. But let me tell you this. In most of the research that we do or that we conduct, okay, we normally want to go beyond exploratory analysis. Okay, because we're seeking for information. At times we may be interested in why something happened, Okay, we want to see the role played by some predators on the occurrence of the outcome. So in most of those studies, what we conduct both explanatory and inferential analysis. I'm going to say that again. Most of the research study, okay, most of research study, okay, it is going to be a combination of exploratory analysis and inferential analysis. And why do we actually need exploratory analysis? As given by John Tukey in 1970, John Tukey believed that before we can do anything inferential, we need to first do a detective work of trying to, understand our data set. Of course, you know, the relationship between researcher and the data set is synonymous with the relationship between physician and patient. So before a physician can make a recommendation of effective treatment, the physician need to first understand the patient. So by exploratory analysis, we want to get to know our data set. Okay. And the moment we get to know our data set, of course, that is going to point us to the direction of the appropriate statistical methodology that we actually going to use at the end of the day. Okay. But if you take a look at this work that I'm projecting now, this from the title, okay, they want to focus on the exploratory analysis. They don't want to do anything inferential. Now, they have some data set, and each data set, each observation in the data set represents a drug related visit to the emergency department of a hospital in the United States. Okay, drug related issue. Okay, now I want you to take a look at that drug related issue. Okay, and we want to exploit this data. Of course, exploring the data, we we're actually going to look out for different age brackets. We want to look at the day of visit. We want to look at after they pay visit. Okay, where do they go next? Okay, okay, so we actually want to provide statistical insights based on the data set available. Okay, let me tell you this. Um, if we want to provide, when they come visiting this emergency section of the clinic, they're gonna have their record. I believe, when you go to clinic, you're actually going to be handed a questionnaire where they want to get to know you. They're getting data from you. Okay, from there, okay, from the data that we have, okay, we're able to have this frequency table. This is a frequency table. Now, when you take a look at this frequency table now, I really want to know the age distribution, okay, of drug related admits. Okay, I'm not referring to all patients. I'm only referring to the patient, that are drug related. I'm talking about drug related admission. Does that make sense? Now, when you take a look at what I have, okay, we're able to know the percentage of each age bracket that paid a visit. Okay, less than 5 years, 5.8%. 6 to 11 years, 1.4%. Now, this is going to give me an opportunity looking at the table to be able to know the largest, the age bracket with the largest percentage of visits. And of course, I think I'm seeing 15.3, right? 45 to 54. Can you see that? Age 45 to 54. Okay, has the largest percentage. And of course, the lowest percentage is, the less equal to 5. Yeah, 5.8. No, no, no. I think I see 5.6. Yeah, 12 to 17. Can you see that? Okay. So this is giving an information. And you can see here, if I call this a table 1, I'm actually giving a kind of description. Okay. Because if I don't actually, you know, write this, okay, that data set may be representing something else. Maybe the percentage of those who actually visit a fun fair, or those who visit maybe Disney World and so on like that. So, and that's why you need that description. Okay, that's very essential. So what I'm doing now, very essential, where either in exploratory analysis or in differential analysis. I told you when you're conducting differential analysis, it is very compulsory you start with an exploratory analysis. Okay, so um, that is that. Now I actually want to move. Now, in an exploratory data analysis, like I said, we're actually going to have graphical summary. Okay, we're going to make use of graphs and plots a lot in describing, because we're actually describing. Okay, now as you can see, right now, you know, we actually having what I call a line plot, a line plot of case type by age. Okay, and that very line plot shows the proportion of cases within each age group. Okay, and that is if you take a look at what I have right now, drug could be related to different kind of stuff, like having accidental injection, adverse reaction, over medication, or maybe from alcoholism, detoxification, and so on like that. So many variable, poisoning, suicide, and so on like that. Okay, there could be a reason why somebody is visiting hospital, okay, and that's maybe that is due to drug related, okay, and it could be any of this that could lead to that. Now, based on the record, can we have a way to have a graphical plot that would depict, the percentage of the visits across ages, uh, within a particular, across a particular variable? So take a look at that. So you I think what I'm going to advise when you are working on your project and something like this come up, I will advise that you should use colors. Colors. Okay, colors. Okay, 5 and under. I may use green, while 6 to 17 red, 18 to 24 blue. Does that make sense? Different colors. With different colors, you'll be able to easily identify, a particular age bracket. So this is giving a lot of information. Okay, we have the percentage of within a particular age bracket. Okay, that their case is related to accidental or injection, or to adverse reaction, or to over medication. Does that make sense? Or something like that. There will be suicide, poisoning, and so on like that. We can tell, okay, with this particular graph. Okay, now, you know, let me tell you this. When you take a look at the difference between a dot plot because you can see you have a dot before they connect that. The dot plot is used in a small sample visualization. A dot plot retain individual data point, compared to histogram or bar plot, where the individual data plot data points will be grouped into bins. Okay, but here, okay, you're able to retain individual. Now, do you know that another way I can actually, if you take a look at this now, I need you to pay attention to what I have right now. Take a look at this guy now. Okay, now you know what is going to happen. If you look at the title, I want to talk about the age of visitor by sex. I want to be able to compare in each age group. Do you know what I want to compare in each age group? In each age group, I want to know whether male is more than female or female is more than male in each age bracket. And again, I'm actually going to suggest that you should use different colors. Okay, I'm talking about male and female. I can decide to use blue for male and use red for female. Okay, now if you go back, you'll be able to see under. Let me quickly show you this. Okay, if you take a look at this guy, you'll be able to compare two bars, one for male, the other one for female in that age bracket. So what I'm doing now, you actually gonna have an opportunity to compare the proportion of male and female in each age bracket. Does that make sense? In each age bracket, okay. Now you're gonna see I think in most of them, let me see. Yeah, if you look at that one, five under five, you're actually gonna see more. We have more male than females. Okay, so and if you go back to 6 to 11, we still have more. We have more male than female. Where we have more female than male, I think more female than male in 12 to 17. Okay, and okay, if you look at 65 and over, this is 65 and over. Okay, talking about this guy now. Okay, can you see that 65 and over? 65 and over, we got more female than male. And let me tell you this. If we want to go inferential, okay, if we want to go inferential, we're now going to ask a question. Why do we have a significant males than female or female than male? Okay, but right now we are only having a graphical summary of the situation. We may not be able to answer a question, why this, why that? Okay, now I want to go if I want to look at it um age specific, and what I want to look into now, please, I need you to pay attention. If you look at five and under, okay, number one, I'm actually comparing sex, okay, male and female, but I'm comparing male and female within the reason, that lead to the visit, either suicide, okay, detoxification, adverse reaction, and so on like that, okay, which means I'm focusing on three things. Three things. Number one, majorly I'm focusing on sex. I want to distinguish between male and female. Okay, between male and female, I want to distinguish. I want to look at the proportion of male and female, across each variable. What are the variable here? You can see, and the one that is so glaring, okay, that you can see. In some, it doesn't exist. Okay, in some, like if you take a look at this, right? Okay, it's like there's no any data point for that, but I need you to pay attention this, to this, right? That's visible, right? To this, okay, to this, the very small one, and to this. Look at that. But that will give us opportunity to know that for 5 and under, it is adverse reaction. But let me tell you this, the reason why this depicts reality. We do not expect a child that is 5 and under, okay, that is treated for drug use to have issue with suicide. Can you see that? You can see nothing there. Or to drink alcohol or to be detox. You can see that. So the major reason for them here is adverse reaction. You can see that accidental injection. Okay, as you can see, and another that is the one that is actually visible. Does that make sense? Okay. Is there any question on others? Is there any question here? Is there any question? Okay, so and you can see in the hand I actually wrote, I said bar plot of age by sex. Okay, and I gave a further description. I actually said the plot on the left shows the breakdown of age for each sex, e.g., the sum of all bars for female has to be 1. Why is it that the sum of all bars have to be 1? Because we're talking about proportion. Proportion is probability. Okay, and each plot in the group of 4 on the right shows the proportion of case, type by sex. So take a look at that. Now, is that another one? Now, I want to tell, what am I doing here? Okay, at times when they visit the clinic, okay, where do they go after? Are they going to remain in clinic, or they're going to go back to their home, or they're going to go to jail? Or, so if you take a look at what you're seeing here, please pay attention. Okay, I need you to pay attention. You're actually going to see for each category, okay, and what we have in the horizontal axis is whether they go back home, okay, whether they go back home or jail, okay, or they actually gonna remain, they're gonna be in ICU, or they're gonna have a surgery, or some even die and something like that. Okay, this is what happened after the visit. Okay, and we want to know what happened after the visit for each category, for each age category. Does that make sense? For each age category. So 1, 2, 3. So the horizontal one actually represent all of these. Does that make sense? Any question on that? Where they go after they visit the clinic? Okay. So we're actually gonna understand the percentage of those within a particular age bracket that go back home or go to jail, okay, go to jail or go to somewhere else or ICU or so it depends on the situation. Okay, so this is the proportion of age group. Okay, now uh another thing here, and I need you to pay attention now. Okay, I have a bar plot here. If you really want to understand what it does, I said bar plot of time of visit by age. This plot shows the proportion of each age group that arrives at the emergency department during different times of the day. Now, you know what we want to do now? We want to put into consideration the time of arrival, okay? And the time of the day has already been, grouped. Some arrive midnight to 6 a.m., okay, midnight, 12 a.m. to 6 a.m. Some arrive 6 a.m. to noon, some noon to 6 p.m., and some 6 p.m. to midnight. We got 4 categories now for the part of the day. Now, you know what we want to do right now. This time around, I need you to pay attention. See what we're doing now. We actually, if you take a look at, let's take a look at this particular age group. I want to believe not everybody in a particular age group that will come at the same time of the day. So the I mean, sorry, the comparative, this Instagram, is actually gonna let us know that. Take a look at this guy now. Like I said, I will advise that you also use a different colors. Okay, use a different colors for you to be able to know. And of course, oh my God, can you see the biggest bar? The biggest bar is the dark one, and that corresponds to 6 p.m. From 6 p.m. to midnight. So which means we under five and under, the majority of under five and under actually arrive, okay, between 6 p.m. and midnight. Does that make sense? You can also investigate for each of the category. This is going to give you information about that for each category. Is there any question? Okay, you can see all of these are very important. Why do you think the management of the clinic need this information? They need this information ahead of, based on this data set now. Okay, they actually want to plan. They need to put a plan in place because they know that, okay, in this time of the day, we are expecting more of this category. In the other time of the day, we are expecting. So I think they need that information because they don't want to be overwhelmed by arrival of this patient. Some of them may arrive they may be in a very critical condition. Okay, so take a look at that. Okay, now this is another information. Okay, we want to look at it. I need you to pay attention. I want to focus on five and under. You can do it for every other one. Now, the five and under here, you know what you actually want to talk about within a particular age bracket. Okay, we really want to know, okay, those ones that arrive at a particular time, and we also want to have opportunity to see where they go after. Okay, now I'm going to spare my time on one age bracket. Okay, I want to talk about five and under now. Okay, give me 1 second. Let me talk about let me do this. Maybe I should go to adults. Okay, let me talk about this group, 30 to 34. Okay, now, and in 30 to 34, uh, I want to focus on this guy, those who arrive at 6 p.m. to midnight. So those who arrive at 6 p.m. to midnight, uh, this particular part is giving us information about where some of them go after the arrival. Does that make sense? You can see some go to jail. You see that? You see the dots. Some go to, if you want to know what the dot means, you need to read that on the vertical side, the proportion on the vertical side, if you really want to know the actual percentage of those who actually end up in jail. Okay, those who die, those who have a surgery, those who actually, that are in ICU. Okay, so that is the information. Okay, now, and of course, the same way you use a dot plot, okay, you can actually, if you want to achieve the same, okay, you can, for instance, if you are no longer interested in the time of the day, but this time around, you are interested in the season they arrive. When I say season, okay, I really want to know, there are 4 quarters in a year. Oh, I want to know the percentage of those that arrive between January and March, those who arrive between April and June and so on, like that. So I will advise when you take a look at the color here, I will advise you have them in colors, different colors. So if you take a look at what I actually have here, okay, I'm actually focusing on five and order, okay. We will be able to know, okay, we're going to be able to have the opportunity. For instance, if you take a look at this guy, okay, we are those that are due to accidental or maybe accidental injection, the bars are kind of very very close in terms of when they arrive in the quarter of the year. Because if you see the bar are kind of very close. But when you take a look at this one, give me 1 second, I'm gonna clean up. There's one that is, if you take a look at this guy, you're actually gonna see during January to March is the biggest. Can you see that? During January to March is the biggest, but biggest for which category or different or for which variable? Probably advanced reaction. Okay, advanced reaction. Okay, so take a look at that. So this is going to give you that opportunity, you know, why you have more of this because of the title targeting exploratory data analysis. And that's why, okay, the analysis is more of a graphical analysis. We use a graphical representation when it comes to exploratory data analysis. Okay, now you already have a lot of graph you've generated, and you need to be able to back that up with scientific writing. Okay, you want to generate a report. Okay, now we can generate reports on that. I need you to pay attention now. Okay, based on what you're seeing here. Okay, where we're talking about location after visit by age. After they have visited the hospital, where do they go? Do they go home? Do they go to jail? Do they go, here we're talking about drug abuse. Do they go to jail? What happened to them after? So based on what you are seeing now for each, different age category, and I need you, based on that, you know what I said? I said most patients, okay, go home after ED visit. How do I know that most actually go home? I'm going to tell you why I know. Oh my God. Why I know. You take a look at this, right? Can you see that for five under? Okay. Can you see that? Okay. Can you see that? Don't forget the first one is representing home. Did anybody see that? That has the largest. And that's why I say most. Okay, most actually go home. Okay, most. So the reason why we may not be able to say all, okay, is because there's possibility you could have another one where it's not up to that. But we're gonna say, okay, most patients go home after. More when I say most patients, I've actually I've combined, or I've looked at all the groups, and I realize, it's the same. Now, so I said that now I'm doing a reporting now. Okay, I'm doing a reporting now. You are interpreting what you see. Okay, interpretation matters. Okay, interpretation matter. And I said here, based on what I see, okay, I said, other inpatient care or transfer is the second most popular disposition. Now, let me tell you this, what they want here. They can actually, I want it to rank. Okay, we are ranking across, we're pulling all the age bracket together now. And what are we ranking? We're actually ranking where they go. Okay. And we're using the percentage, we're using the proportion to be able to say that, okay, majority go home, and the second on the is that, okay, they actually get transferred to inpatient care. Okay. And I said, here, a noticeable proportion of elderly 45 and over go to other inpatient care, and the proportion of cases sent to inpatient care increases as the age goes up. Now, let me tell you this. What you can actually see here is if I have a particular variable in mind, and the variable is, inpatient care, I want to believe, we have inpatient care, like those who probably going to stay in the hospital, right? Am I right? For the inpatient care, like they're going to stay in the facility. Now, for the inpatient care, the hospital really want to know, like, as they want to know what is the trend as age is increasing. Is it going to be going up, or is it going to have a downward trend or upward trend, or there's no appreciable movement? And you can see here it goes up. Okay, it increases as the age increases. Okay. Okay, now, like I said, we're telling story. Okay, now this is the time of arrival. We can also summarize that. The time of the day. Okay, you can summarize that. You can see what I did here. Okay, so we're telling story about that. Okay, now when you take a look at what I have here, okay, this one, this is interpretation. Okay, I'm actually within a particular age bracket. We really want to partition the patient into the time of arrival, the time of the day of arrival. Okay, now I said for age 34 and below, ER visit occur most often at night, 6 p.m. to midnight. Okay, it occurs 6 p.m. to midnight. And now, am I going to know if it is if you come back here? Okay, don't forget, as I use color, so 6 p.m. to midnight. The darkest one, if you take note, I said 34 and below. Okay, if you take a look at this all the way here, that's what I mean. If you look at the comparative bar, you're actually gonna see what dominate is the dark one that correspond to 6 p.m. 6 p.m. to midnight. And that was why I collectively, give that interpretation. Does that make sense? Take a look at that. But when you use different colors, yeah, like I said, you gotta use different colors, okay? When you use different colors, it's gonna be so easy. It's gonna be so nice, and you can easily see, the levels of the part of the day can be well distinguished from the other. Okay, and I said the older patient 35 and above is, the visit occur more often in the afternoon. So like you can see, now I'll say something else. You can see I focus on three paragraph, one, two, three. Okay, why do I do that? Okay, you see, I talk about 34 and below, maybe the youth and below, and I talk about from the maybe youth and above, and I also talk about that. Take a look at that. Okay. So this is descriptive in nature. This is not inferential. Okay. This is like describing what happened. Okay. Now take a look at that. Okay. There's another one. And this is the interpretation. Okay. Now it goes all the way. But you know what? I want to spend some time here. You know, if you want to compare a specific scenario with the one in the United States, like the general one in the United States by census. Okay. For instance, we may want to compare age distribution of DAWN subjects. Okay. Don't forget the the DAWN that we just talked about. Okay. The DAWN, I'm going to show you so that you understand what I mean. The DAWN actually means this, okay, drug abuse and warning network, okay, drug abuse. Now, let me tell you, the data that we're using now, this particular data actually came from from a hospital in the United States. Okay, from a hospital in the United States. Does that make sense? Okay, that's what I say from a hospital in the United States. But based on what we see here, based on the distribution that we see here, we may want to compare with what happened in general in the United States. Okay, we may want to compare what happened in general in the United States. Okay, what happened in that particular hospital. Okay, now I say here the age distribution of a DAWS subject closely matches the US population for young children and older patients 45 and above. Now, don't forget, we got different age categories. Okay, we got different age categories. Okay, the age categories that we got, let's say we go to five, we got that. That would be two, three, four, five, and six. Okay. Now, when you look at that number, we now compare to maybe the one for national when census was conducted. Okay, now if you take a look at this, 5.8 and 6.5%, to me, they are not statistically significant. There's no statistical significant difference. Okay, now if you check 45 and above, take a look at this. Oh my God, take a look at that. Even 65. Okay, you're actually going to see they are very close: 14.8, 13.0, 25.5, 26.4. So if you compare what happened nationally with the distribution in the hospital on that consideration, then you actually are going to see that. And let me tell you this: when you look at 18 to 44, for instance, okay, when I talk about 18 to 44, okay, this, okay, and that. You actually, in fact, not just 18 to 44, even this guy here, you see that? That one is 7, the other one is 17.5. That's a huge gap. 14.7 to 9.9, that's another huge gap. 32.2 to 26.6, that's another huge gap. But let me tell you this. Do you know that a statistical significant tests can be conducted to be able to see whether whether there's a statistical significant difference between the two. But right now, what we're trying to say is, okay, what we see in terms of numbers, okay, does that make sense? Okay, so that is that. Is there any question on this? Aro, is there any question? Is there any question? Now, I need you to take a look at this. I'm having a plot right now. I'm having, for instance, what I'm doing here, please pay attention. What I'm doing here is to look at, I want to have a kind of plot for 500, okay, across uh, different drug related reason. Okay. Okay. I want to be able to say for 505, okay, I want to look at the 505 across the variables. Okay. I also want to look at 6 to 7 across that. Like I said, I will advise you make use of, colors. Okay. Here. Okay. And as you can see, I said, this is going to give us a pattern. We'll be able to know the percentage of a particular response variable here. There are so many response variable. The response variable 1, 2, 3, 4, 5, 6, which is the age bracket. Okay. And what I have in the horizontal axis is the, drug related reason. Okay. Now I said something here. A large proportion of the drug related ER visit is due to advanced reaction. Okay. So why do I say due to adverse reaction? Because when you look at the adverse reaction in so many categories is higher than every other one. Can you see what I'm saying? Okay, adverse reaction, adverse reaction in all age bracket, okay, is the highest compared to other reason. Does that make sense? That's what you can figure out. Okay, take a look at that. And we can also talk about the second most, I said the second most common reason for elderly is over medication. For instance, I can just pick on a particular response, which here is the level of the categorical. We have a categorical response where if I want to focus on 65 and over, then I will be able to see, okay, it is actually due to over medication. That's why they are there. Okay, so aside that, okay, this is, when you are comparing male and female and you want to give a report. This one here, you can see here, you are comparing male and female in each age bracket. Okay, male and female in each age bracket. This is going to give you an opportunity. If you want to focus on a particular age bracket, for instance, if I'm focusing on 65 and over, okay, if I'm focusing on 65 and over, I'm actually going to say more female than male. Take a look at all of that. Okay. And here, this is where we actually put everything together. You can decide if you want to look at everything together, okay, looking at everything together, maybe you want to have a way of comparing the proportion of male and female across each age bracket. You can decide to say, okay, I only want to focus, I want to look at the age bracket one at a time. Okay, now if you take a look at this, here I said, okay, among 5 and other, more male visit the ER. Okay, more male, because when I look at that at different reason why they, a different reason, relating their drug use to, you're actually going to see more male than female. So you'll be able to see, in each age group, you'll be able to see which one dominates between male and female. I remember yesterday, I was actually making a call to a clinic. I want to schedule my daughter, one of my daughter for, vaccination. And they they actually want to see when the female doctor is going to be around. So they need information about whether it's going to be a female doctor or it's going to be a male doctor that they're going to recommend at time that doesn't apply to all cases or situation. Now, here, like I said, I'm writing, and I say here we have chosen to focus our analysis on two vulnerable group age. Okay, young under 5 and under, and elderly 65 and over, to learn more about their drug-related ED visits. Okay, this is their focus. Okay, even though they've also have opportunity to see the distribution across ages, but their main focus of interest is the vulnerable ones. Okay. I think I actually put like this is not clear. I also put this, okay? It's very clear here. You can check the canvas. I've uploaded all of this. Um before I go today, like I said, on what is it called? On Friday, there's going to be, graduate panel. Okay, the graduate panel will give you opportunity to ask questions from, alumni of the university, or those that are actually um, maybe in their graduate studies, or they've graduated from the university. They are now working in an institution. It could be a government institution, it could be a research institution, or working in the civil service, or even or maybe they are even doing their business. And of course, you need to get prepared to know the kind of questions that because I believe we live in a world by information. what I want to do now or what I want to do in the future. Maybe some people are currently doing it. Is it possible I gain from their experience? It's not as if we're going to do it exactly the way people are doing it because, every human being is unique in their way. But, if what I'm having in mind to do in the future and some people are currently doing it, it is better for me to share from their experience, and that will prepare me for that particular future. Okay, so check the canvas. You're going to have information about the venue of the meeting. It's going to be a joint meeting between this class and the other class, just like the way we did it the other time. And also, before I go, I extend, you know, the more consulting video, indefinitely. I extend the deadline for submission indefinitely, because I think I will still have one or two persons that have not been peered. And because of that, I'm not going to punish anybody for that. So, I will advise if you have not been peered, okay, I will advise that you send me a message so that I can peer you and you have your mock video done, okay, and of course, eventually submit that. Aside that, I look forward to see everyone on Friday, this Friday, okay? The graduate panel. Is there any question before I go today? Oh, my time is up. Okay. See you. Make sure you all stay safe and have a lovely day. Bye for now, everyone.